Everything in the universe follows a silent, unbreakable rule. Eventually, everything breaks. From the stars above to the machines we build, entropy is the ultimate tax on existence. But when it comes to us, living, breathing organisms, the story of breaking is far more complex. For decades, we thought aging was just wear and tear, like a shoe losing its sole. We blamed oxygen, we blamed metabolism, we blamed the simple passage of time. But new science suggests something radical. What if aging isn't a hardware failure, but a software bug? Welcome to Ariadnology. Today, we look for the exit in the labyrinth of biological time. To understand this, we need to distinguish between your hardware and your software. Your hardware is your DNA, the 3 billion letters of code you were born with. It's remarkably stable. Your software is your epigenome. It decides which of those books are actually read. This software orchestrates how a single cell becomes a trillion-cell human being. But as we get older, this software starts to make mistakes. It forgets who it's supposed to be. This is called epigenetic noise. The instructions become garbled. Think of it like a memory leak in a computer. The system is still there, but it's becoming sluggish. But if the problem is software, can we just reset it? This isn't science fiction anymore. We have a way to measure exactly how old your software is. It's called the Epigenetic Clock, pioneered by Steve Horvath. By looking at chemical tags on your DNA, we can predict your health with eerie precision. Your chronological age is simply how many times you've orbited the sun. But your biological age is how much damage your software has accumulated. Shockingly, 2 people born on the same day can be decades apart biologically. So, if we can measure the clock, why can't we just turn it back? The answer lies in a discovery from 2006, the Yamanaka Factors. These 4 genes can take an old skin cell and turn it back into a youthful stem cell. It's like taking a corrupted file and restoring it to its original version. In labs, we've used this to make old mice young again. Their hair grows back, their eyes clear up. But there's a catch. If you reboot too much, you lose the file entirely. In humans, this would mean your cells forgetting their identity, a heart cell forgetting how to beat. The goal of 2026 is partial reprogramming, rewinding the clock without erasing the identity. Large-scale companies like Altos Labs are spending billions to master this balance.
But why did we start breaking in the first place? Why hasn't evolution fixed this? This is the selection shadow. Evolution only cares about you until you reproduce. Once your genes are passed on, you are, biologically speaking, disposable. This is the disposable soma theory. Nature chooses babies over long-term repairs. If you spend all your energy on repair, you might be eaten by a predator before you have kids. So evolution picks the live fast, die young strategy for most species. But there's another theory, antagonistic pleiotropy. Early success, late failure. Genes that help you grow strong when young can turn into killers when you're old. For example, a gene that pumps calcium into your bones to prevent breaks might later pump that same calcium into your arteries, causing a heart attack. We are effectively the victims of our own early life success. So, if nature won't save us, we have to save ourselves through geroscience. In 2026, we are moving from treating disease to targeting longevity. Instead of fighting cancer or Alzheimer's one by one, we are attacking the root cause, the aging process itself. This is a war on zombie cells, also known as senescent cells. These zombies refuse to die, and they poison everything around them. Senolytic drugs act like a biological cleanup crew, removing the toxic waste.
By clearing the zombies, we can extend our health span, the years we live without pain.
But longevity isn't just about drugs. It's about your mitochondria, the power plants. As we age, these power plants sputter and leak, reactive oxygen species. Keeping them efficient is the key to cellular energy and long-term vitality. This leads to the mito-microbiota axis, the link between your gut and your energy. What you eat determines the signals your mitochondria receive. In 2026, we can monitor this in real time using continuous metabolic sensors. AI looks at your data and predicts you're getting sick, weeks before you feel it. This is anticipatory healthcare. We build the bridge before the car reaches the cliff. But as we approach the cure for aging, we face a massive ethical divide. Will immortality become a luxury for the 1%? A biological caste system? If we solve death, do we also solve the urgency of life? Without a finish line, is the race still worth running? Some argue that death is an essential element of evolution that prevents stagnation. Shorter lifespans allow for faster adaptation to a changing world. By dying, we make room for new ideas, new genes, and new possibilities. It is the ultimate generational turnover. But what if we could have both? Wisdom of the old and energy of the young. This is the Longevity Society of 2030. In this future, your age is just a number on a chip, not a physical limit. We are finally beginning to understand the lattice of life. It's a system of coordination, not just a collection of parts. When the coordination fails, the music stops. That is aging. Longevity research is about keeping the conductor's baton moving. We are exploring information theory in biology. If we can preserve the signal, we can preserve the life. This brings us back to our software. Can we debug our own existence? Scientists are now using AI to find longevity compounds in nature. AI can simulate billions of chemical reactions in seconds, discovering drugs that were once thought impossible. But the most powerful tool might be epigenetic reprogramming, restoring the cellular memory of being young. We are becoming biological architects, designing our future, one cell at a time. But as we extend our stay on Earth, what happens to the planet? A world with no death is a world with no room for the new. Longevity requires us to rethink everything: work, retirement, love. If you live to 150, retirement at 65 makes no sense. We are entering the era of perpetual learning. Staying curious might be as important as staying healthy, because in the labyrinth of time, the only way out is through knowledge. Aging is a puzzle, and for the first time in history, we have the pieces. We may not be immortal yet, but the biological horizon is shifting. We are the first generation to decide how we break, and perhaps how we stay whole. Death is not the enemy. Stagnation is. Evolution means embracing the change. Every day, we learn a new letter in the language of longevity. The exit is there. We just have to keep moving. Subscribe to Ariadnology, and let's find the way together. Let's explore the future of life.